Hello, folks. This is Mr. Tolbert, Mr. Tolbert's physical science class. And the slide you're looking at right now has to do with some information that's going to help us understand things that surround flight, because flight is one of the things that we talk about in our physical science class. We're going to talk about, and if you don't have a word map or a place to write this, you might want to jot some of these things down because they all kind of meld together to help flight happen. Viscosity is the resistance of a fluid to flow. Bernoulli's principle, what you see there is this particular picture over here, where you have the potential energy, the kinetic energy, the pressure energy, have to maintain to be constant. And if you change anything, any one of these variables in those, if one thing goes up, two must go down. Or if one of those goes up, the other two must go down. Or if one goes down, the other two goes up. So you've got to vary any of those three variables along a streamline. Airfoil is basically the design that you see here, the wing design that allows air to, or the air molecules to roll down the ramp of a wing and allow flight to happen. Okay, matter flows when a force is applied. Fluids can roll down hills. Okay, that helps us understand flight. So as I was saying, Bernoulli's principle is important because it allows these variables to change, and they've got to stay consistently balanced as they move.
In 1738, Swiss mathematician and physicist Daniel Bernoulli formulated a principle that relates fluid velocity to its internal pressure. The Bernoulli's principle states that the total energy in a steadily flowing fluid system is constant along the flow path. Hence, an increase in fluid speed must therefore be matched by a decrease in its pressure.
All right, so that gives you some of that information there. Now, let's get into this flight. So one of the most important applications of Bernoulli's principle has to do with airplanes and things that fly. When a plane is moving, the pressure on the top of the surface of the wings is lower than the pressure beneath the wings. That's because if you look at this particular picture here, think about the air molecules as little marbles. These marbles are rolling faster downhill than they are rolling underneath the wing, which is a flat surface. Just like if you were on a skateboard. If you're on a skateboard and you're going downhill, it's going to go faster if you are going down a steeper hill than on a flat surface. That works the same way for this airfoil, or for the air that's flowing over the top of a wing. Because that air is moving faster, there's less of it on the top of the wing as it is below the wing, which creates a pressure differential. Okay, and what happens there is, because there's less of it, a lower pressure on top, lower pressure on top, you gain higher pressure on the bottom, there's more of them. So it's going to push the airfoil upwards and things begin to fly. Hopefully this video will come out here.
Ask anyone what a plane looks like, and most will tell you
Come on. There we go.
tube with wings. NASA researchers are trying to change that. They're testing a design for a flying wing called a blended wing body, or BWB, which would be more fuel efficient and carry more than today's aircraft. Technicians installed a 5% scale model of a BWB in the Langley full-scale tunnel, owned by NASA's Langley Research Center in Hampton, Virginia, and operated by Old Dominion University in Norfolk, Virginia.
It has a 12-foot wingspan, and we basically fly this model in the wind tunnel. It tests techniques.
Because that blended wing basically says the whole thing is an airfoil and the entire plane is a wing.
Two pairs of opposing forces act on an aircraft in flight. Thrust, the forward driving force provided by a propeller or jet, is opposed by the friction of air known as drag. Lift is the upward force developed as air passes by an aircraft's wings. Weight, the downward force resulting from the Earth's gravity, is the opposing force that must be overcome by lift for flight to occur. Planes are designed around wings, and wings are designed according to the rules of aerodynamics. If a vertical plate is subjected to fast-moving air, a turbulent and chaotic airflow will occur.
All right, so that's the last little bit about flight. Hopefully that gives you some information about that. Where does viscosity fit? Well, think about this. Air is a fluid, and which means it's going to have certain places where air is thicker. We think of where you're thinking, well, where is air thicker? Well, sea level. Sea level air is thicker because there's more air. So the atmosphere there's a lot more air being weighed down. Then as you go up, like if you were to jump on a rocket ship and go up towards outer space, there's less and less and less molecules of air, which means there's less of it. So the thickest air is going to be down towards the surface. Also, with viscosity, as in anything else, if you increase the temperature, that's going to make that fluid want to move around a little easier, which is going to affect how the air moves over the top of the wing as well. So I hope that was great information that helps you understand flight a little bit more.